Okay, this is Ms. Whitaker here. I'm just going over the graphs, tables, and functions test review. Please go over this and go over each question. Make sure that you understand, especially problems like this first one and first few problems where we're dealing with nth term and sequences. Please make sure you are very well versed in the difference between arithmetic and geometric sequences, and make sure that you know how to find the function of a sequence of numbers. So let's just begin with number one. Please follow along and make sure that you're not just recording the answers, but you're recording how to solve it, and make sure you know the basic concept, because these questions will not be the same questions as you see on the test. All right, number one. Tell whether the sequence of y values is arithmetic or geometric. Then find y when n equals 5. All right, first of all, y values. So this is the row we're looking at, the y row. So in this, we're going to be looking at the pattern like we've talked about. This is what you studied in elementary school, and you're really good at identifying the pattern in a sequence of numbers. And this one, hopefully you quickly see that we are adding 3 every time to get the next number in the sequence. So we know that next number is going to be 16. Now we see that the answers for A and B both have y equals 16 when n equals 5, but we need to make sure we understand what kind of sequence this is. Because we are adding the same thing every time, then it's going to be an arithmetic sequence, and when n equals 5, y equals 16. This has nothing to do with our vertical relationship between the position of the number and the number itself. All right, but we are going to, on number 2, that's what we're doing. When we're looking for a function or a rule of a sequence, then we're looking for the relationship between a number in a sequence and the position where it sits. And it's always going to be y equals something that has to do with n. This is a huge concept that you need to make sure you understand. It's not like number 1 when we're looking from one number to the next. We are looking now at the number and what it has to do with a position that it's in. Remember that n is position of a term, the first position, the second position, on and on. Remember, please, please, please make sure you get that. N is the position of the term. All right, so our sequence starts with 19.5. Now I told you before, when we just have a sequence of numbers and they don't give us a table with an n row, that we're going to make our own. So I'm going to use a different color for this. I'm going to put my n row on top of my sequence of numbers. All right, so what I'm looking for, I'm not going from 19.5 to 20.5. That's obviously just adding 1 every time. That would be an arithmetic sequence. But what I'm looking at is from the 1 to the 19.5, from the 2 to the 20.5, to the 3, from the 3 to the 21.5, from the 4 to the 22.5. So a great way to do this, if you can't identify what's going on, is just to evaluate every answer choice. Now, look at this one, letter A. It says 19.5 times n. So if I take my n here, right here at the beginning, if I multiply by 19.5, yes, I do get 19.5, but this has to work for every term in the sequence. So if I take my second position, if I'd say 19.5 times 2, I do not get 20.5. So just because of just starting with the second number in the sequence, I know that letter A, this function right here, cannot be, so I'm going to rule that out. It has to work for every term in the sequence. All right, let's look at letter B, 18.5n plus 1. All right, does that work for the first one? It does work for the first one. If I do 18.5 times 1 and then add 1, I get 19.5. But again, it doesn't work for the second one. 18.5 times 2 is going to be more than 36, and then adding 1. So that doesn't work. So I'm going to rule it out, because if there's even 1 that it doesn't work for, it cannot be the function of the sequence. All right, let's take a look at C. 20.5n minus 1. Again, it all works for the first one. 20.5 times 1 is 20.5, minus 1 is 19.5. So it works for the first one, but it doesn't work for the second one. 20.5 times 2 is 40 1, and then minus 1 would be 40. So 40 would have to be in the second row, so C is wrong as well. Hopefully it's D. All right, let's test it. First position, if n is 1, then 1 plus 18.5 is 19.5. Again, it works for the first one. If I plug in 2 for n, the second position, 2 plus 18.5 is 20.5. If I plug in 3 for n for the third position, it'll be 21.5. So this is working because remember that n is the position. Now let's look at what a possibility that you might make a mistake. Now you might notice that we're adding 1 every time, so you might just choose this one because you see adding 1, but that's not right. It's 18.5 times the number in the sequence, in the position of the sequence, and then adding 1. So that is not the rule for this. So please make sure that you understand when you're finding a sequence, it has to do with a position and then something that has to do doing something to that position. I'm adding, subtracting, multiplying, or dividing, or something like that. It could be 2 steps, but in this case, this is just a 1-stepper. All right, let's move on to number 3. All right, number 3, at the beginning of the year, Jason had $40 in his savings account. He plans to deposit $20 into his account each month. By the end of January, he's going to have $60 in his account, $80 by the end of February, $100 by the end of March, and so on. Write a function that describes the sequence. Then use the function to predict how much he'll have in his account at the end of the year. All right, first of all, we know that he has $40 to begin with. So we know we're going to start with 40. And then he plans to deposit $20 into his account each month. So I'm going to, let's see, let's look at each one of these. 40 plus 12 times x. Is that going to be a function that describes the sequence that I'm looking for? I don't think that's going to be it. 40 plus 12x. Yeah, there's 12 months in a year, but x is going to be the number in the sequence. That's going to represent the month right there. So x is going to represent the month, and I'm doing $20 a month, so which one does that match? It matches C, because I have my $40 I'm starting with, and then I'm doing $20 a month, and x would be 1 for January, 2 for February, 3 for March, and I'm doing $20 each of those months. So please evaluate every one of these. $60 plus a month is not going to be right. That's not going to be right. And then $60, this 60 is not right. We're starting with $40. So that's the $40 is what we're starting with, so it's between A and C. And he's putting $20 in each month, not $12. All right, so your answer is going to be C for that one. All right, look at number 4. Gloria drives her daughter to school in the morning and then comes back home. She stays home until she has to go pick up her daughter from school, and then both return home again. Which graph best shows the situation? All right, first she drives her daughter to school in the morning. So I'm assuming she starts at home, so that rules out D and A. So distance from home, they're starting at home, they go to school, and then she comes back home. And then she stays home until she has to go pick up her daughter from school, and then they both return home again. This is obviously represented in the graph in letter B. This is saying that mom stayed at school all day, so it's not C. All right, just take a look at your graphs, and you'll figure out, just with common sense, which one tells the story. All right, number 5, identify the type of transformation. Let's look at the orientation of the car. They're both pointed in the same direction. So this is a slide. It's obviously not a flip, so it's not a reflection. It's not a rotation around a point. This is definitely a translation. It's just a slide to the right. Make sure you know the difference between all of those. All right, let's look at our matching section here. An input-output relationship that has exactly one output for each input. This was key right here. This is called a function. Just think of that function machine. We have one thing goes in, and then one thing comes out. All right, number 7, the value that results from the substitution of a given input into an expression or function. The value that results, that would be your output. So that's f. The value substituted into an expression or function is your input. All right, number 9, an ordered list of numbers. That is a sequence according to the notes we wrote down. All right, number 10, a sequence that has the same value added each time to get the next term in the sequence is an arithmetic sequence. That's F. An element or a number in a sequence is a term. We also went over those in the notes. Number 12, a sequence that has every term multiplied by the same value. That's a geometric sequence. So that's D. All right, let's move down the page. Number 13, a pair of numbers that can be used to locate a point on the coordinate plane is your ordered pair. So that's H. The vertical axis on the coordinate plane, remember vertical is up and down, so that's going to be your y-axis. Number 15, each of the 4 coordinate plane regions divided by the x and y axis. So 4 coordinate plane regions, those are your quadrants. So that's E. Number 16, a plane formed by the intersection of a horizontal number line called the x-axis and a vertical number line called the y. So a plane is your key word, so that's going to be coordinate plane, so that's C. Number 17, the horizontal axis. Horizontal, think of horizon, it goes from side to side. That's your x-axis. And number 18, the point where the x-axis and the y-axis intersect on the coordinate plane is called the origin. It's where it originates, so try to remember that word. All right, let's move down to 19. The coordinates of 3 vertices of a rectangle are, and they give you these vertices right here. Now I'm going to use this graph on number 20 just to demonstrate, but you can always draw your own graph. Matter of fact, I'll just do that over here. Okay, let me create my graph real quick. It doesn't have to be perfect. All right, letter A is at 1, -5. Now remember that in our ordered pairs, it's x, then y. X comes first. X is our horizontal, y is our vertical. So I'm going to go over to the right 1 and then down 5 for -5. So 1, 1, 2, 3, 4, 5. So this is where A is. And B is at 1, +3. So I go 1 and then I go up 3. So here's B. C is at 10, 3. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, roughly. So it looks like a rectangle. I'm going to go up here and go over here. So it looks like my other vertices is going to be over here somewhere just by drawing it. Notice I drew the picture to help me understand this. So I know I'm supposed to go to the right 10, and then I'm going down -5. So it's going to be 10, -5 for my other vertices that I'm missing. Please notice that I share this x value and this y value to find your exact points. But please draw a picture to help you understand. All right, look at number 20. Graph the translation of triangle ABC 4 units up and 6 units to the left. Now remember when we went over translations and reflections and I told you go 1 point at a time and then redraw. So we're going to start with A. We're going to go 4 up, 6 left. So 1, 2, 3, 4, and then 6 to the left. 1, 2, 3, 4, 5, 6. Notice I'm halfway in between, so make sure you are hold on. Make sure you're going in between. So 4, 1, 2, 3, 4, 5, 6. So here's my new A. Take your B, go up 4, 6 left. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's my new B. And then C. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then redraw. And there's your new figure. So remember, 1 point at a time, and then redraw. No need to worry about translating the whole figure at the same time. So 1 point at a time. And just make sure you follow the directions really clear. Make sure you see the directions and how far they're going to go. All right, number 21, that we're going to graph this reflection across the x-axis. Now, please circle whichever axis you're going across. And what I'm going to do first is darken that axis so I know my figure and every point has to go across that line. So here's E. E is 1 below the line, so the new E is going to go above the line. 1. And then the F is 3 below, so it's going to go 3 up. The G is 3 below, it's going to go 3 up. And then I'm going to redraw. And there's your translation across the x-axis. What do you think a translation across the y-axis would look like? Think about that for a second. If I'm flipping that figure, what would that look like? Here's a little hint. It would look just the same. So think about that and just keep in mind which axis am I flipping across. All right, we're going to skip 22 on rotations. We are actually on this one, you would go around C, that would stay there. In this A, it's actually just a 180 degrees, so everything's going to be the opposite. So this line right here is going to be over here. We are 1, 2, 3, 4 out, so 1, 2, 3, 4 out, and then this is going to be coming down, and it's going to look something like that. All right, number 23. We're not going to worry about rotations right now. All right, number 23, identify the quadrant that contains the point 3, 6. So even if they didn't provide the point, you should be able to graph 3, 6. So over 3, up 6. That is in the first quadrant. Please make sure you know your quadrants. Those are Roman numerals. You can still say 1, 2, 3, 4. Please notice that we start in quadrant 1 where they're both positive. Quadrant 2, our x's are negative and our y's are positive. In quadrant 3, they're both negative. And in quadrant 4, our x's are positive and our y's are negative. So please know your quadrants, know where it starts, and then go counterclockwise. All right, number 24, write and graph the ordered pairs from the table. Here's the graph down here. That's kind of hard to do. So our ordered pairs, please remember what I said. If you have an x and a y, put them together and make an ordered pair. So here's an ordered pair, -3, -2. Then we have 1, -1. And we have 5, 0. And we have 9, 1. And then just make sure you know how to graph it. I'm going to go ahead and graph it right here. -3. All right, -3, -2, I'm going to go 1, 2, 3 to the left, and then down 2. So negative, negative is in the third quadrant. So it's going to be right here. And then I've got 1, -1, so I go to the right one, and then down -1, so there's my point there. I have 5, 0. My 5 is on the x line, so 1, 2, 3, 4, 5, 0 is right there. Then 9, 1 is going to be 5, 6, 7, 8, 9, and then up 1. It looks like it could make a line. So that's roughly my graph there. All right, let's move to 25. Make a function table and graph the resulting ordered pairs. So we have a function here, and we're going to create a table using the inputs that they've provided here in our x row. So let's just plug in under our rule, we're just going to plug in our x values. So 3 times -1 squared plus 6. 3 times 0 squared plus 6. 3 times 1 squared plus 6. 3 times 2 squared plus 6. Now let's solve that. What's a -1 squared? -1 times a -1 is +1. Then I'm going to multiply by the 3. +1 times 3 is 3, plus 6. Our output is our answer of 9. Please make sure you're really careful about solving these, especially when you have negatives involved. All right, 0 squared. 0 times 0 is 0. 0 times 3 is 0. 0 plus 6 is 6. 1 squared is 1 times 1, that's 1. 1 times 3 is 3. 3 plus 6 is 9. 2 squared. 2 times 2 is 4. 4 times 3 is 12. 12 plus 6 is 18. Now I have an x. I have a y. I'm going to put them together here in the ordered pairs. That's all I have to do here is put those together, and it creates ordered pairs that I can graph. And so we'll graph it on here. We've got a -1, 9. So we go a -1, and then we go up 9, which is about right here. We go 0, 6. So 0, 6 is going to be right here. Remember, our 0 is our x, so we're staying right there. And then we go up 6, and then we go 1. 9 is going to be right there. And then 2, 18 is going to be right there. This is going to make that parabola shape, like we said, because of the x squared. When I square a negative number, I have a positive answer. So that's why our bowl is pointing up in both directions, even when our x is negative. All right, number 26, last problem. Look at this sequence of numbers. Which of these expressions can be used to find the nth term in the sequence? So nth term, we're talking about a function. Now remember, if I have a sequence of numbers and I don't have my n row, then I'm going to make it myself. So just put it right on top of the numbers. This is my n row. N is the what? N is the position of the terms. Please don't forget that. Don't ignore n. That's the biggest part about this. All right, so I'm not looking at what's happening from the 3 to the 6 to the 11 to the 18. You could probably figure out a pattern. However, you could not create a function from that. Now it looks like I'm going up 2 every time. So I'm adding 3, and then I add 5, and then I add 7, and then I add 9. But that's not what I'm talking about here. What I'm talking about here is the relationship between the number in the sequence and the position where it sits. So what am I doing to get from 1 to 3, from 2 to 6, from 3 to 11, from 4 to the 18? Now this looks like it's going to be a two-stepper. So look at letter A. Is it 2 times n? 2 times 1, is that going to give me 3? No, it's not. So I don't even have to go beyond the first one. Let's look at letter B here. Let's plug in our n's. That's all we're having to do. So the first position, n is 1. I'm actually going to create a sequence every time here. Let's go back to A. Let's create a sequence of numbers for the rule of 2 times n. So in the first position, it's going to be a 2. In the second position, it's going to be a 4. In the third position, 2 times 3 is 6. I hope you understand n is the position, so I'm just plugging in those values. So for letter B, if I plug in 1 for n, if the first position, what number belongs there? So just solve this expression. 1 squared is 1, plus 1 is 2. 2 squared, so n is 2. In the second position, n is 2. 2 squared is 4, plus 2 is 6. 3 squared in the third position, 3 squared is 9, plus 3 is 12. 4 squared is 16, plus 4 is 20. So obviously I know that this sequence is not the one I'm looking for. All right, look at letter C, n squared. So the first position, 1 squared is 1, plus 2 is 3. So far so good. 2 squared, 2 squared, 2 times 2 is 4, plus 2 is 6. So far so good. 3 squared, 3 times 3 is 9, plus 2 is 11. So I'm looking good so far. 4 squared is 16, plus 2 is 18. So this is looking pretty good. I'm going to go on to D just to check it. So far I think it's C. All right, 1 squared is 1, plus 1 is, is 2. So already on the first one I know that D is not the answer. C is my expression. It's the only one. So when you have problems like this, just evaluate every answer choice. There's only going to be one answer choice that fulfills the needs for every term in that sequence. All right, please make sure that you understand everything in this review, and email me if you have any questions. Be prepared for your test.